All right, here's another old school whiteboard quiz review problem from Math 2, quiz number 2. We are trying to graph the absolute value function y equals 1/4 times the absolute value of x minus 3 plus 2. On the graph, I've already put the parent function, which is f of x equals the absolute value of x. So remember, we have y equals a times x minus h plus k, which we write like this sometimes. And in our problem that we're doing right now, our a value is 1/4. Our h value is positive 3. And our k value is positive 2. So a is 1/4. H is 3 and K is 2. One problem that people had on the last quiz is not understanding this part about how H is positive. The formula has a negative there all the time. So this negative sign right here is that negative sign. So the negative sign comes along with the formula. If there was a plus sign, it would be because the H that was substituted in had a second negative, which would change this to a positive. But we have just a negative 3 showing in our absolute value. So we have x minus a positive 3. That minus sign, that's a positive 3. Our H is positive 3. So our vertex on our problem will be at 3, 2. So when we make the graph of our y equals 1/4 times the absolute value of x minus 3 plus 2, we're going to start with the vertex at 3, 2. So I go 3 to the right, 1, 2, 3, and up 2, and that's where my vertex is. Now this problem has a little bit more complicated a value than we've been used to. On this problem, our a value is a fraction, and we haven't done a problem like that before. Our a value is also positive, so we know that it's going to open up. So the difference between the parent function, which has an a value of 1, and our function, which has an a value of 1/4, when you graph the parent function, you go up 1, over 1, up 1, over 1. Or you might say rise 1, run 1, rise 1, run 1. Well, on our problem, we're going to rise 1 and run 4. So our problem is going to look like this. I'm going to go up 1 and over 1, 2, 3, 4. And I'm going to go up 1 and over 1, 2, 3, 4. And our graph will look like this. And the way that you describe that graph is it's a horizontal translation of a horizontal translation of 3 to the right, a vertical translation of 2 up. That puts our vertex at 3, 2. And then it has a vertical shrink of 1/4. So here, when we went up 1 and over 1, that has no vertical shrink. But if you go up 1 and over 4, that causes a vertical shrink. Here's another old school whiteboard review problem for Math 2 quiz number 2. They want us to simplify this expression right here. So this expression has many problems and we need to fix them so that it is in simplified form. We are going to fix them by replacing the 0 exponents. We don't have 0 exponents, so we won't need to do that. Relocate the negative exponents. We do have a negative 3 here, so we will need to relocate that exponent and its base. We need to remove the parentheses, so we're going to remove those. We need to rewrite multiple occurrences of the same variable. So here there's 2 occurrences of x, so we need to rewrite that, and 2 occurrences of y, so we need to rewrite that. And then in the end, we need to reach for our calculator to find out the numerical values that are left. So on this problem, I think my first step is going to be to remove the parentheses. So in order to remove the parentheses, you need to multiply the exponent on the outside by every exponent on the inside. A common mistake is that people forget that this 2 has an unwritten 1 for its exponent. So you need to multiply that green 1 by that green 5 in order to do the problem correctly. So we're going to have 2 to the 5th, x to the 20th, y to the 40th over x to the negative 15th, y to the 30th. So every exponent that was on the inside got multiplied by 5 because 5 is the exponent on the outside. So we've removed the parentheses. I think what I'm going to do now is relocate the negative exponents. So I'm going to make a fraction, and everything that has a positive exponent is going to stay where it is, and everything that has a negative exponent is going to move either from the top to the bottom or the bottom to the top. In this case, this x to the negative 15th, which is on the bottom, is going to be relocated to the top. So I just relocated all of the negative exponents. Now I think what I'm going to do is rewrite the multiple occurrences of the exponents. So I have x to the 20th and x to the 15th. In order to rewrite that with only one x, I need to add the exponents. And so that will be 35. Okay, now I also have multiple occurrences of the y's, but this y is on the top and this y is on the bottom. So here we added the exponents because they were both in the numerator. Here, when one is in the numerator and one is in the denominator, you have to subtract the exponent. So 40 minus 30 is 10. So now there are no longer multiple occurrences of x or multiple occurrences of y. So the only thing left to do is reach for my calculator and figure out what 2 to the 5th power is. So we've got 2 to the 5th power is 32. So I have 32x to the 35th, y to the 10th. In this old school math problem for Math 2, quiz number 2 review, they want us to rewrite this using a radical symbol. So right now we have an m with an exponent of 2/3. Anytime you have a fractional exponent or a rational exponent, it can be written with a radical sign. And whatever the base is in your exponent problem, that's the radicand in your radical problem. Whatever your denominator is in your exponent problem, that's your index number in the radical problem. And whatever your numerator is in the exponent problem, that is your exponent in the radical problem. So remember that this number right here, the denominator, becomes your index number. The base becomes your radicand, and the numerator becomes your exponent. All right, on this old school whiteboard Math 2 Quiz 2 review problem, they want us to graph f of x equals 1/2 to the x power, an exponential function, and they want us to identify the percentage change. So this is going to be an exponential decay problem because our b value is in between 0 and 1. And we're going to start to graph it by making a table. So we're going to substitute each x value in for x. So our exponent will be changing from -2 to -1 to 0 to 1 to 2. And we'll calculate the value with each change. So if I do 1/2 to the -2 power, that will equal 4. If I do 1/2 to the -1 power, that will equal 2. 1/2 to the 0 power, remember anything to the 0 power is 1. 1/2 to the first power, anything to the first power is just itself. And 1/2 to the second power will give me 1/4. Sometimes it's easier to graph if you write these as a decimal. And so now we need to make the graph. We really don't have enough points to make a very accurate graph, but with exponential functions, because the values can get very small, and if we kept going this way, they would get very large, it's hard to fit them all in a graph. So I go -2 and up 4, -2, 1, 2, 3, 4, -1 and up 2, 0 and up 1, 1 and up 1/2, and this is where we're estimating a little bit, 2 and up 1/4. And so our graph will look something like this. And as our x values get bigger, our y values are getting smaller. That's exponential decay. Now, in order to identify the percent change, remember we just have to find two consecutive numbers. Why don't we just use these two consecutive numbers right here, and we're going to find the percent change between x value -1 and x value 0. So percent change goes like this. Percent change equals our final y value minus our initial y value over our initial y value multiplied by 100. So in this problem, we started with 2 and we ended up with 1. So our final y value was 1. Our initial y value was 2 over our initial y value, which is 2. And we're going to multiply that times 100. So we're going to have 1 minus 2 is -1 over 2 times 100. So as a decimal, that's -0.5 times 100 would be -50%. And it's negative because it is decreasing, and that is called exponential decay.